My name is Prashant Varshney. I'm the head of product for Azure MSWB, part of the strategic missions technology at Microsoft. Today we're going to talk about the new service, the Azure Modeling and Simulation Workbench, and how it is able to solve some of the collaboration challenges in the design process. So for this, let me take you back in time. 20 years ago, this is kind of like a typical scene of a design room where multiple teams would just be coming together. The brightest minds in the industry will be doing some transformational chip design. They will be interacting with each other, sharing data, also doing some joint debug and analysis sessions with the EDA vendors, the IP vendors, and so forth. And this was the state of the art at the time, just because there was no other option to be able to share the data and still be able to protect the intellectual property. But the funny thing is this is 20 years ago. In some sense, this is the state of the art even today. In many scenarios, if you look at the product complexity has gone up, the IP sensitivities have gone up, and the infrastructure that we have is really limited in the way it can provide the security and ability to be able to collaborate with the data effectively. So if you look at the product complexity that has grown over time, these limited infrastructures, non-scalable business processes, the non-scalable frameworks are not able to keep pace with the growing demand of the complex systems. So developers, this is actually starting to impact the developer productivity as well. So developers are now looking for a way to get better control over their infrastructure so that they can actually use it as a competitive advantage. And by the way, this is not a problem just for the semiconductor industry. This is true across various industry verticals, as you see out here, aerospace through automotive, etc. And the reason is that their engineering frameworks seem to be very similar in nature. So if you look at, of course, semiconductors, chips are done hierarchically. They involve a lot of participants, stakeholders, vendors and IP providers, the customers. They have to come together to be able to build a chip. Similarly, in aerospace, for example, you would have a company like Lockheed. Is this okay? Are you guys able to hear me okay? Companies like Lockheed who are building out a new aircraft, they have to collaborate with their engine makers like Rolls-Royce, who is developing the state-of-the-art engines, and they have to put the models together to be able to simulate the entire aircraft. Or in the automotive, let's say Ferrari is developing the next generation race car, and they have to now collaborate with Bridgestone, who's making the next generation tires, and they've got to share the models, put it all together so they can do an integrated performance test. Or even like in the oil and gas industry, where Chevron's working with their IP vendors or ISVs like Halliburton, their tools to be able to do some geological data analysis or orchestrate large-scale HPC clusters for doing reservoir simulation. So a lot of these engineering systems are very similar. They all have common data sets. They are all collaborating with teams that are outside of their organizations. They are all sharing data. They are all sharing tools and IPs. So it's very similar nature from that perspective. So these gaps basically pose a two-pronged problem. On one side, we've got this product complexity and the research complexity growing dramatically over time. And on the other hand, you've got this intent of trying to put together a system which is now bringing multiple parties together. So like I was saying, in the case of the chip design, you've got IP being sourced from various IP vendors. There are ISVs like Synopsys, Cadence, and Mentor, Ansys. The folks have to be brought together to be able to debug or analyze something or co-develop. customers have to be in the loop. There's a design services companies that come in and they do portions of designs. All of that has to be managed in a system, in a single system. So this causes a big disparity in what the systems are able to do today. And so if you look at the traditional collaboration model, right, let's just walk through this. So what you see on the right-hand side in the blue box is like a typical enterprise network. The host here, which is the enterprise, is basically having their own identity access management. They want to collaborate, let's say, with a guest. They want to collaborate with the vendor. So they would onboard the vendor. This onboarding process is highly intricate. It's very cumbersome. They've got to have the contracting done, vetting processes, etc. And then they will get an identity. They will get a login in the enterprise network, and therefore they can then be able to get into the firewall chamber and be able to collaborate in their engineering systems. Typically, this firewall chamber is kind of like something that is cordoned off as part of the larger enterprise network. In many scenarios, it's actually a physical room, like I showed you on the previous picture. And now, if you just imagine the guest is coming in and they're able to collaborate here, but if they were to bring in their own IP or data into the mix, that adds to the complication further, just because the corporate, legal, and IT and InfoSec teams have to be involved from both the corporations before any action can happen. So that just elongates the process significantly. So of course, it's a very long setup time for an infrastructure like this. In addition to that, there is fixed hardware. When you put together this mini network, you have to choose some compute infrastructure. So you would say, hey, I've got this scenario where I'm debugging this particular problem with a tool. So give me a network where I can demonstrate this, bring in the EDA vendor or whoever else you're working together with. They can reproduce the problem and be able to validate the solution. Okay, you need 1,000 cores. You get those, they are as a fixed hardware. What if you wanted to try 2,000 or 5,000 cores? You cannot. It's a fixed infrastructure. You can't reduce or increase it once it is hosted. In addition to that, it's also a logged investment. So typically for super infrastructure heavy steps in the flow, you would have like specialized hardware. The hardware with larger memory, for example, they are all logged into this infrastructure just because you have to reproduce a complex problem. Once you're done with that, you don't want to tear this down because you never know when you're going to need it again. So highly inefficient in the way these things are put together and a very cumbersome and slow process. Now, in addition to the infrastructure, there is also the development process that we believe is also becoming outdated. It's not able to keep pace with what standards that are out there already. So I'm talking specifically about the physical systems here, which includes, of course, chip design and product services that are connected with the physical systems. So we believe that this time is right now to be able to move away from the physical system, the linear development methodology of developing, testing, manufacture, to a methodology that is a lot more common in the software domain, where it's a more iterative process, which really emphasizes continuous feedback and incremental progress through the whole flow. Well, this will really allow leveraging a lot of the tools and development methodologies that are already established in the software domain and hugely successful. So why to invent something new for physical systems, for chip design, where you can leverage something that's already available? So such a system, or such a platform, or such an environment is not only going to be able to solve our problems, challenges today, but also set us up for advancements coming in the future. So there are 5 foundational principles that we believe are necessary for any environment like this, right? The first one is the scalable and performant. The platform needs to be able to manage the performance. These workloads are complex, the engineering systems are complex. The workload I mean, the infrastructure needs to be able to have the high performance network to be able to scale with the requirements of the projects. And automating, when time is a crucial resource. So we want to make sure that the infrastructure is automated to the extent that we give the control back to the developers, the designers, who can then manage their own infrastructure. It should be easy to use and automated so that they can focus more on innovation rather than setup and configurations. And collaboration, of course, that has to be a centerpiece of everything. Anything that you're doing in modern days requires collaboration. So enabling an effective collaboration between the organization. So organizational boundaries, geographical boundaries should not be barriers anymore. Just sharing data and IP across these boundaries should be effective and seamless. Security obviously is paramount. We have to make sure that the data and the users are safe and secure inside the environment. It's kind of like a vault for your intellectual property. So you have, restricted access, and every action that happens in the environment is all traceable and recorded. And of course, AI enabled, so you've got to be able to leverage the latest and greatest technology that's out there and be able to do smart design processes. So remember this room that I showed you early on? This was 20 years ago. Actually, this is me sitting in one of those rooms just 2 years ago. That's why I know this problem is still not solved. In fact, the idea for Azure MSWB was born while sitting in one of these rooms. We were sitting at one of these customers and trying to solve a timing closure problem. And sitting in a room for multiple days, and just thinking that there's got to be a better way. And that's when we built the Azure Modeling and Simulation Workbench. So this is really a secure workspace built for collaboration, right? So really giving the control back to the developers, designers, to be able to build as well as control their infrastructure, their developer environment by themselves, fueling innovation. And so, of course, it's got to, we've got to test and verify the pillars that we just mentioned over here. So let's just go over that in more details. So scalable and performant. Now, specifically EDA, silicon design workloads are quite intense. Their infrastructure requirement is very specific, and the flow is complex. At every step in the flow, they have different requirements. So the performance infrastructure utilizing high-performance compute and high-performance storage, orchestration, all of this needs to be hooked up in a way that the overall performance that you get in the cloud meets or beats what you see in an on-prem environment. Otherwise, the total cost of ownership, when you start including the infrastructure cost and the EDA tools, would not even make sense. So this Azure MSWB really leverages the high-performance SKUs and the high-performance storages, Solar solution with orchestration piece to make sure that we are delivering the performance that's required for every specific workload. I'm going to show you some more details on the next slide. But on this slide, if you look on the left-hand side here, this is an example of one of those build-outs that is done specifically for an EDA workload, and how we are putting together the compute, various types of storages, caches, license servers, orchestrators, schedulers, done in such a way that it really optimizes the performance for specific workloads. Just to give you a little under the hood of what it involves to actually be able to put together infrastructure like this. So on the right-hand side, you see here, for every step in the flow, the tools' characteristics are very different. The EDA tools are built differently. They have various legacy issues, newer architectures, older architecture mix, scalability is limited. The way the engines are built, they can be more monolithic in nature versus split out. And therefore, they have very different requirements from an infrastructure perspective. So you've got to understand exactly what VM types, what storages to be used to be able to optimize the performance. And we've got a gamut of different VM types that we have introduced in the recent past that are really great fit for those specific workloads. So for example, oh, no pointer here. The FX series, this has a 1 terabyte of RAM and a reasonably high frequency CPU, the 4.1 gigahertz. This was announced 2 years ago. That was specifically done for EDA workloads because especially the back-end workloads require large memory to core ratios. Then ESV5, these are all Intel-based VMs, AMD-based VMs. The next generation that's coming up, which is HX, that has an even higher memory, 1.4 terabytes. And then we've got really giant monster machines with up to 12 terabytes of RAM, which are required for some of the deep backend type of workloads like ERCs, et cetera. So the MSWB infrastructure is really providing you the curated list of what these VMs need to be able to optimize those specific steps in the flow. And these are all pre-installed. They come with Red Hat 8, the latest operating system. But then more importantly, they actually come with all the OS dependencies from these EDA tools already taken into account. And then storage and VMs are automatically mounted as well. So all of this stuff, we have, in the spirit of trying to make it easy to use, we have really delivered all of these configurations in a very simple to use form. Typically, if you go to a VM page, a virtual machine page, or a storage page, there are hundreds of configurations. But we could have filtered that out to what's really essential for the developers. If you really want to scale out, you need a few VMs. Why do you have to go through 1,500 VMs and try to pick out the right configuration? You just say how many you want and you're done. Similarly for the storage, if you want more, just go click a button, you have more storage, right? So we have tried to simplify the interface as much as possible. Now, our team is obsessed with ease of use and automation, like I was saying, and we really tried very hard to really make this system as push button as possible. From initialization to fully deployment, the whole system comes up in less than an hour. And all the infrastructure that you saw previously, the VMs, the storage, networking, orchestration, license service, all of this stuff comes pre-installed, ready to go for the users to just bring in their design data and just get started. Even the license server has been automated to a point where you still need the license key, of course, when you get from the EDA vendors. We supply the license key, and then everything else, the deployment of the licenses, running the LMGRD processes, making sure the licenses are visible to all the VMs on the network, within the workspace, is all done automatically. The collaboration, obviously, is the key. This has been one of the founding principles for the service. It really makes sure that you're enabling effective collaboration by providing the privacy for each team. And I'm going to show you some of that here, how these chamber architecture allows for multiple teams to come and collaborate, still have their own privacy, but then allow for selective sharing of data. So let's double click into the collaboration piece. So this chart looks very similar to what you saw before. That was traditional way of doing things in an on-prem environment. Now we're moving to cloud. So that's why you see the Microsoft logo here. So this is Azure. The green box is a platform managed infrastructure. On the left, the gray box is Azure. And on the left, you have customer tenants. So you got the host, and then the host comes in. They have their own identity and access management. They have their own Entra ID. They get authenticated there, multi-factor auth, and they land into their own chamber, which is the work environment. This is where all the data is kept, and that's how the teams are operating. If they need to collaborate with another team or another individual that they want to onboard, in the older method, they would have to go through onboarding process. In this case, let's say a company wants to onboard an EDA vendor. That EDA vendor may already have their Entra ID set up in Azure, their identity and access management setup already available. So we use the B2B tenant capability to be able to authenticate the guest in their own Entra ID, in their identity management. So now onboarding this guest becomes highly simplified. You don't necessarily have to go through the processes you had to do before, because those folks already have their identities well established and you're authenticating them against that. But this still has a problem, because the folks that you onboarded just now, they land into your own chamber. So you're sharing the entire data that you have in the chamber with them. What if the host does not want to share all the data with them, the entire network with them? What if the guest is bringing their own data and they don't want to share it with the host? So The host can then provision another chamber for the guest. This is going to be private for the guest, where the host can then copy the selective data that the guest needs to see and be able to push that into chamber 2. So in a joint debug scenario, for example, if the host, being in a semiconductor company, is having a challenge with the EDA tool, they would be running their regular development work in chamber 1. Let's say for RTL simulation, for example, if they have a specific problem with one test, then they would just copy that one test and the relevant design files, RTL design files, put that into the shared storage. That then can be accessed by the EDA vendor. They can replicate the problem in their own chamber. And if they wanted to, they can bring in their own IP, their tool set, their debug tool sets or whatever, to be able to analyze that in their own chamber. So host does not have access to chamber 2 and therefore completely private. Now, what if you have more than one collaborator? So the architecture scales. You can have as many chambers as you want. You can add as many shared storages as you want and configure them in the way your collaboration scenarios work. You may want a way to collaborate amongst all the 3 chambers, or you may want a collaboration only in chamber 1 and 2 or 1 and 3, whatever that scenario is. You may have central PDKs that's supposed to be used by multiple design teams. That is the shared storage that is then shared across all the chambers. Or you may have specific design files that goes to another sub-team only. So those scenarios can all be implemented in this environment. Security obviously is always top of mind for us. So we are building on top of Azure infrastructure. And we are leveraging the security that's built in at the IaaS level, from the physical data center infrastructure all the way to cybersecurity. And then we also leverage all the, the compliance certifications Azure already has, more than 100 compliances, which are industry and region specific. On top of this IaaS, we build further security scenarios as part of the PaaS service, the workspace. So things like storage isolation, what you saw as shared storage. There are ways that those storages are being isolated so that we can keep the data, we can protect the data. Role-based access control, those chambers have roles and responsibilities, administrators and users. So people who are onboarding and they're coming into those environments, they have certain abilities. So administrators and the workspace owners, they have ability to control who is the administrator, who's the user, and change that as we go. And then of course, data import and export. This is a really unique one. The way we have devised these chambers are kind of like data diodes, right? They do not have any internet connectivity for a reason, because you do not want any way that the data can be exfiltrated from this environment. So there are explicit protocols that have been built for importing and exporting data from this environment. No story is complete without talking about AI. But there are lots of other people who are talking about how AI is transforming the world, so I'm not going to go there. I'm only going to say this, that Microsoft is obviously spearheading a lot of this innovation. The Azure OpenAI, which is an enterprise service that's built on top of OpenAI, all the way from content generation, summarization, code generation. They're really having a deep impact on the developer ecosystem and very broadly across various industries. So what about chip design, right? There is a ton of work that's going on when it comes to generative AI on how you can use that in chip design domain. And there are many partners, the EDA vendors, the foundries, design service partners, the customers themselves, and academia. They're trying out various things at this point, right? All the way from design authoring, where you have RTL development, to verification domain, which is where a majority of the work is going on right now, all the way down to the system, device and system level. So what our team is trying to do is to work with our partners to try and productize some of these solutions using the Copilot platform and the OpenAI frameworks. And then, of course, as we go on, as we look to the future, we are looking to embed some of these capabilities as part of the MSWB platform as well. So the platform is in public preview, and it can be used for production at any point in time. It has been used as part of the RAMP program. The RAMP program is a government US DoD initiative that was launched back in 2020, and that was targeted to try and modernize the microelectronics ecosystem. Some of our government friends are sitting over here, part of the RAMP program. So Microsoft got the charge for building out the cloud-based secure platform. And with the support from all the industry leaders over here, the logos that you see out here, we built out the platform, and then it was then validated by Raytheon and BAE by actually doing their chip design in this environment. The RAMP program still continues on, and we've got many more defense industrial-based customers who are onboarding for their proof of concept as well. If you'd like more information or would you like to onboard on that, please get in touch with us. We are also launching today our MSWB Alliance program. So this Alliance program really brings together the EDA vendors, the foundries, the IP vendors, as well as the design service providers to really create like an ecosystem around collaborative design in the cloud. So it really helps the customers, our mutual customers, like the developer community like yourself, to be able to now get the solution that's vetted by the partners. We get all the pre-approvals, getting the tools and methodologies that are pre-validated best practices within the MSWB environment, and be able to accelerate the adoption of this new tech and be able to leapfrog on the development process. So there is more information on this, so please get in touch with us, people on the booth or myself after this talk. We can certainly discuss, and if you want to participate and be a part of the Alliance, you're more than welcome to do that as well. And we are very happy to announce the Cadence, Intel Foundry, NetApp, Siemens, and Synopsys as being our initial partners for this. Okay, this is going towards the end now. So there's a bunch of different ways that you can get in touch with us. There are multiple QR codes. I'm going to step out here, so if you want to take a picture here. But generally, if you wanted to stay up to date, sign up for access to MSWB if you wanted to do a POC. If you want to request a meeting with us at DAC, our team's upstairs in level 2. And then, of course, in general, if you want to outreach, for us to kind of reach out to you and set up something. And of course, you could visit. I really want to invite you to our booth to learn more, of course, about MSWB in general, but then also try it out yourself. We've got a demonstration set up, and you can try the service by yourself. And then, of course, there are a bunch of partner presentations also happening in the booth. And then last but not the least, we've got an outstanding tutorial that our team has put together that's happening tomorrow at 10:15 a.m. In the level 2 lobby. So I really hope to see you all there. Thank you.